Am I audible? Please respond in the group if I'm audible to you all, and also tell me if the screen is visible to you. Okay, thank you. Good morning, everyone. Let us begin with some of the discussions that have been going on in the group. So, Harshit has asked me if, before starting today's class, please explain the into out spiral matrix of M into N. Okay, so like we discussed, the actual logic is going to be similar to what we looked into. The only thing that you have to do here is that, so this is the logic that we looked at, right? This logic, whatever you're going to be looking at, and this particular part where we say that since you have to start off with, so for any particular loop out of these four loops, you're going to start from the 0th index and go on up till row number -1 or column number -1 for respective loops, right? And the outer loop, as I said, should be working for and should be keeping a track of the number of rows and the number of columns and at which particular row or column you're currently at, right? So you can, for the question that was there in the exam, for that you actually implement the same thing and then you reverse the output. So whatever output you get, you reverse that, and that is going to work for any particular row or say any order of matrix, you can say. So you had to actually prepare this code in such a way that it is going to work for any order of the matrix, and for the simple output of what you got for the previous test, you have to reverse the output. So a lot of you had answered with the same approach, which is to reverse the spiral output that you get, which is the correct way of doing this. This was the only trick in the question that was a part of the test, and yes, nothing else. So I think one of you, I cannot find the message right now, but you said that you have some problem in dynamic 2D memory allocation and you're unable to. I think you mentioned that previously as well. So for that, can you please ping me personally, and we are going to resolve your queries in that way, because if we take up a topic that we've already looked into again, there will be a lot of loss of time, and since we're short of time, let us begin with today's lecture. So today we are going to have a different kind of discussion. So it is going to include okay, yes, so it was Sumit. Please ping me personally, and any doubts that you have will be resolved through, let us say, uh, whatever doubts you have, you can ping those to me personally. Okay, so for today's class, we are going to have a different kind of a discussion. And so this discussion will be basically on a project. So you might have looked into the PDF that was shared with you, which actually involved the schedule and what topics are going to be a part of this bootcamp. So on sixth day or on Saturday, or the first Saturday of the boot camp, we were going to discuss a project on image processing. So we are going to move ahead and look into uh, OpenCV. So first of all, we are going to understand how so since I am considering that none of you have much background in image processing, and if you have, then okay, so let us just create a poll and see uh, how many of you have a background in image processing. Hmm. Okay, so I have created a poll on the group and would like to know your answers to this question which I have posted. Okay. Okay, so I can see very less votes. Can you please go ahead and vote here? Yes, why can I only see 34 votes? Yashika, you're not able to join the class. What you could do is that try and switch your internet service. Okay, okay, okay. So I think my own internet wasn't working properly. Okay, yes. So got some more votes as well. Okay, I can see a total of 200 votes. Okay, now it's become 323. Okay. Yes, so the image processing part that we are going to be looking at is using OpenCV libraries. Okay, so let us get started. A lot of you are saying that we are new to this part, so let us just begin. So this particular class is going to be just an introduction part. So by introduction, what I mean is I am going to talk about the basic things that you can actually perform with OpenCV, and then we are going to start off by looking at some of the libraries as well, and we are going to look at one very small, let us say, piece of code with which you can actually start off using OpenCV and C++. And now, since uh, it is not always true for everyone that everyone is into image processing. You might have, since you are all in this field, you all might have different interests. It is not really necessary for every student to have an interest in image processing, so we are not going to go into much detail, and we are going to look into only basics of it, and we are going to be towards the end of the class, we are going to be discussing a project and using. So this is going to be a very, very basic project, which like all of you can implement. As I said, since it is not always true that everyone is going to be interested in image processing. Okay, but it is mandatory for all of you to do that project, since it is going to be of a very basic level, and it will be very good if you have that much basic knowledge um, of image processing in C++ using OpenCV. Okay, so we have we have talked about images. So we, you know about images, right? And you know about videos. So what does, let us first understand what is OpenCV, and then we are going to move ahead and understand what that is. Okay, so let us. Okay, so is it visible to everyone whatever I'm writing? I've written image processing in C++ using OpenCV. Is this visible to everyone? We are going to look into, so Ashish, we are going to look into how you have to install it. We have to install OpenCV separately. It is not available under the standard libraries. Okay. Okay, so yes, if it is visible, let us continue. So as we said, we are going to be discussing image processing in C++ using OpenCV. So we say, first of all, let us understand what is OpenCV. So OpenCV, as the name suggests, stands for Open Source Computer Vision. You say open source. The open in OpenCV stands for open source, and CV stands for computer vision. So what is computer vision? Computer vision is basically when you use images and you use videos in order to extract any useful information, and you do that and you do that um, using the computer's knowledge basically. So this is what OpenCV is about, which is open source computer vision. And what is it that computer vision means? Computer vision basically means to extract useful information from images or text or even videos. Okay. Okay. Now, since uh, C++ and a lot of other programming languages uh, provide you libraries for computer vision. So one of those libraries is OpenCV, and OpenCV is not only available in C++, it is also available in Python. Okay, so but today we are going to be discussing it with C++. So what are the different things? Let us first look at what are the different things that you can actually do using OpenCV. And so if any one of those things interests you, that means you can go ahead with understanding OpenCV and performing or taking up a particular project later on whenever you want. So even as a major project towards the end of your graduation. Okay. So what are the applications? Basically, let us understand the applications. So the first application which you can actually perform using OpenCV library and its functions is basically recognition. So recognition in terms of facial recognition, you can say. So it provides functions for facial recognition. You can say face recognition as the first application. Oops. Okay. The next thing that it allows you to do is it allows you to count. So what all things can you count? You can count people, you can count objects, vehicles. Okay, so it allows you this as well. Now, both of these things, recognition and counting, come under surveillance, right? You know about automated surveillance. Both of these things come under surveillance. You can say automated. So all in all, you could say that you can perform automated surveillance. Other things that you can do is, so in addition to facial recognition, it can also perform object recognition. So like for example, a lot of uh, times you might have looked online that people have done projects on, let us say, coin recognition. So recognizing a coin is of which country, or the currency that you have, you'll have images of currencies, and it is going to detect and recognize that which country's currency this is. Okay, so this is also something that can be done using OpenCV. There are other things which, let us say, involve basically they are known as anomaly detection. So let us say if you have you've manufactured a set of products and you want to determine if any of these products is defective, that also can be done using OpenCV. So you will basically require images or let us say videos of the objects that you have or the products that you have, and determine if there is any of the product which is let us say damaged or defective. So a lot of these kind of things can be performed using OpenCV. Recently, I've seen someone on LinkedIn who has using OpenCV created a project which is going to be performing automated surveillance. That is, it is going to count the number of people at a particular event just based on looking at a particular video. So it is going to capture a video and it is going to count the number of people at a particular event, and that is in connection to the you know people limit or the number of persons limit that has been put to an event due to COVID, right? So all of these kind of interesting projects can be actually done using OpenCV, right? So if this brings you a bit of a motivation, let us continue and look at um, how OpenCV actually works, and we are going to also look into different header files which you can use. And yes, okay. So if there are no questions from this particular portion that we just looked at, can we move ahead, everyone? Okay, let us move ahead then. So since we are looking at, so we talked about what are the different applications. We are saying that we can use video, OpenCV on videos as well, and um, on what do you call this, text as well. But we are going to here look at, since we are looking at image processing, let us move ahead in this direction only. We are going to consider looking at header files, and we are going to consider looking at different whatever functions we look at based on image processing only. And if you're more interested in something which is, let us say, processing a video and stuff like that, then you can go ahead and read about it online. It is going to help you a lot. So how accurate is automated surveillance? Automated surveillance, so that totally depends upon how uh, you know, attempt to perform surveillance. So we have different parameters using which you can actually find out the accuracy of whatever you have performed. So for that we have, let us say, we call that as confusion matrix and stuff like that, but we are not going to look at that particular part because that is something very much in detail and that goes to a different part. We are going to only look into basics today. So if you're more interested into it, go ahead and look about it online. It is going to help you a lot. A lot of stuff is available online. Okay. So the first thing, since we want to perform and start off with image processing, so the first thing that you do is you need to install OpenCV. Now, since you're doing it using C++, and you have one of these softwares which is known as VS Code or Visual Studio Code. You can install that as well. So let us talk about this in let us say in steps. So the first step that you are going to uh, be performing is, let us say, install OpenCV with VS Code. So VS Code is like a editor. So like you have Dev C++ as an editor, we have VS Code as an editor, but as the name suggests, it is Visual Studio Code, and it is going to help you a lot whenever you consider using OpenCV in C++. So so this is one of those softwares which you can install, and with this install OpenCV. So since OpenCV is open source and it is not available with the standard libraries, you will have to install it separately. We are not going to go into much detail of how you're going to do it because a lot of documentation is available online. You can easily go online, even refer to the OpenCV's own documentation. It is going to explain you step by step about how you can install OpenCV. So yes, do that with VS Code as well. So you'll be able to find out a lot of tutorials online which will help you to install OpenCV with VS Code. So go ahead. The first step for you to do that is do this. Now, so since we are talking about OpenCV with VS Code, there was this other thing which I wanted to let you know, but it has skipped my mind now. But okay, as soon as I can recall it, I'll just let you know. Let us just continue with this. Uh, yes, so this is the first step which you do. Yes, so the other thing that I wanted to let you know was that whenever you are using OpenCV in C++ and you're creating a particular program, it won't be running on Windows until and unless you have a software like VS Code. It will run on Linux. So a lot of tutorials will also let you understand how can you do it on Linux. If you want to do it on Linux, you can do that as well. But VS Code actually provides a very good interface and it is very easy. So this is what is recommended for you. Okay, so after you have done this, um, let us let us move towards how can you code using OpenCV. So let us first talk about header files. So like you actually create any C++ program. So you start off by, let us say, including the header files and then using namespace, and then you go ahead, write down the main function. This thing actually works in the same way. Only you have to know which all header files you have to include, and under those header files, what are the different kind of functions that are available. Okay, so let us talk about that. So the second step that we are going to talk about here is header files. So although there are a lot of header files that you can use, different kind of header files that you can use in OpenCV for, let us say, image processing. Then you have different header files for video processing. Then you have different header files for text processing. You have all those stuff, but this one of these things that is very simple here is to actually include one header file. So let me tell you what that header file is, and then we will move ahead. So you have this header file which is hash include. You can include it in this way. You say hash include OpenCV 2 / OpenCV .hpp. Okay, so this is one of those header files. So if you include this one header file in your program, you will not have to include any other header file, because it will automatically include all of the necessary header files for the application that you're currently creating. Okay. Okay, so yes, so let me just also write with this that it is going to INCLUDE. Okay, so this is about it. Let us so we've talked about this particular library now. So we basically refer to this library when we actually, so for this is actually for all of those who are new to OpenCV and they do not really know which header file they have to include for which particular part. Now what happens is that as you move ahead, as you learn more about OpenCV, you're going to know which header files you can include, and obviously you can also go ahead and search about it online, looking into which header files will be used in your particular project. But this always helps, so this is one of the plus points that you have. So yes, include this header file and it is going to help you include all of the other header files which are going to be required for your project. Okay, so now all OpenCV classes and functions are in the, so now when we talk about the namespace, you say that the namespace CV, we are going to have a namespace CV which are going to include all of the OpenCV classes and its functions. So uh, let us also look at how you can write that. So you simply say using namespace CV, and this is going to for you include all of the classes and functions under this OpenCV library. Okay, now since we are talking about image processing, let us continue and understand how you can actually load an image and how you can display a particular image. And then we are going to look into what are the different syntax of these functions. So as I said, we are going to look into the basics first, so that you can at least create a small program which will, let us say, input a particular image and output the same image. Okay, so this is the most basic image processing program that you can actually create. We are going to look at that. Okay, so the next thing that we are going to look at here is, let us say, read and load the image. And display, or let us say output image. Okay, so this here, let us look at the different functions that you're going to have. So let us say if I consider the other these header files that we discussed and this namespace, so what is this part of code that we'll be able to write? So we say that, let us say I want to include this header file. OpenCV2 opencv.hpp, and we have the other header file which using which we can actually use the console input output functions, is iostream in C++, right? So you include iostream and you include this file, and now you say I am going to write down the namespace as well. So you say namespace, and you have the CV namespace, and then the next namespace that you have is std. Right, and simply like you use the main function, you have a main function in your program, and inside the main function you can now write down the different functions which are going to, let us say, input the image, process it, and then output the final resultant image. Okay, so let us look at one of those functions which is going to help you read a particular image. So let us say that you have stored a particular image at any particular location on your device. So how can you access it or open it up? So for that, you have this image reading function, which is, so let me first write this statement down, and then you're going to with that understand. So you say mat, let us say mat image im read name of image, let us say. Okay, so like this, and the extension. So if you say it is jpg, let us say this. Okay, so let us first understand what this is and why, what is this syntax, and then we are going to move ahead. So we have this class here, which is the mat class, and this is the object of image. This variable image is now an object of type mat. Okay, and now you're calling this function imRead, which is basically image read and the name of the image. So as this simply shows you, it is going to read a image which is, let us say, of a given name. Okay, now what is this mat? Let us understand this. So for this you need to know that any particular image, it is represented in the form of a matrix. Okay, so I've told this earlier as well, but still, for those who did not attend the classes earlier, an image is represented in the form of a matrix. So is that clear to everyone? Let us also understand how this is possible, and we are going to move ahead then. Okay, so up till this part, am I loud and clear? Has everyone reached up till this point where we are discussing that an image is represented as a matrix? For that, okay, good. So I am going to be sharing a PDF. So how should it be? Should I share the PDF on the group, or the Telegram group, or should I share my screen and simply look into and show you what is the part that we are going to look at, since we do not actually require the complete PDF, but for those who are interested in this PDF, they can go through it completely. For others, we are going to read through a small part if you want. Okay, so I'll share this in the group. Okay, just give me a moment. Let me just share it on the group. Okay. So I am going to be posting a link on the Telegram group. This here is actually a link to a PDF, and so if you want, you can open it up right now. It is going to open up even if you're accessing this particular lecture online, or even if you're doing it on so on your phone or even on your laptop. You can open it up, and we are going to read through some of the let us say some of these lines. This link is to a research paper. So there was this faculty of mathematics who has actually written down this paper, and he's talking about image and its matrix, and its image. So that is what is the title for this. So we are not going to be discussing the complete thing here. It is only for your reference and for you to understand that how can an image be represented as a matrix. Okay. Okay, so if you want me to share the screen as well, let me just do that also. So is the screen visible to everyone? Yes, I have shared it on the screen as well. Please let me know if it is visible to everyone. It is, right? Okay, so let us talk about it then. So you can see here, this is a research paper. We are not going to actually, look into much detail about it. We are just here to understand. We are just here to understand how can an image be represented in the form of a matrix. So we say that, so you can read here. Let us start with this. So you say, let us start with the abstract. So he says that the need for matrix representation by image is clear to all those who work use high dimension matrices. So it basically means that since the an image can be very large in order to store it, so you can actually use a matrix form of its representation, or even vice versa if you want. So that totally depends upon which way you find better. So if your project, it is okay for your project to store an image in its original form, that is fine. Otherwise, if it can store it in the form of the matrix, then good to go. So yes, so it says there is a relation between matrices and digital images. So we are talking about digital image. So it also explains you what a digital image is. A digital image is a in a computer is presented by pixels matrix. Okay, so now you understand. It says that any particular image, any particular digital image can be by its pixel matrix. So corresponding every pixel in image, you are going to have a matrix element. So it says, on the other hand, there is a need, especially with high dimension matrices, to present matrix with an image. Okay. Then it explains you the motive of this work. We are not interested in that particular part, but we are going to look into image and its matrix. So it says a digital grayscale image. So please note, it is talking about a grayscale image here. Grayscale, black and white, right? So it says is presented in the computer by pixel matrix. Each pixel of such image is presented by one matrix element. So as I said, corresponding each pixel, you're going to have one matrix element, and it is an integer from the set 0 to 255, right? So this is another thing that you can note, that any pixel value that you have in your matrix is going to be an integer from this set, which is, it can either take up a value from 0, starting from 0 only up till 255 and no other value. And please note, we are here talking about a grayscale image. Okay. So now you say the numeric value in pixel presentation are uniformly changed from 0. So 0 actually represents black pixel or black color, and 255 represents white pixel. Now you see here, they have also given you an example. They say that you have this grayscale image here, this grayscale image. This grayscale image can be represented using this matrix. So they have given the matrix corresponding to the image, and this is all the pixels that it has. So you see 0 is the first element of this matrix, which is, so 0 actually they said that it represents black pixel. So black is here, this pixel, and white is going to be represented by 255. So the last element and the white color here is represented by 255. Okay, so this is about a grayscale image, and how, so you now know how a grayscale image is going to be represented in the matrix form. So what does it say about color images? It says that color images with RGB color model. So color images can have this RGB color model. It says that with this color model in a computer are presented with 3 grayscale images. Okay. So now you say a color image can be represented using 3 matrices. So these 3 matrices will be of the grayscale form. So for each of these matrix, since you are going to have 3 matrix, for each of these matrix, it's going to be corresponding one color component. So since it is RGB, corresponding R, which is red color, you're going to have one matrix. Then corresponding green color, you're going to have another image. Corresponding blue, you're going to have another image matrix. So 3 matrices make up a colored image. So now, so this was the actual part that we wanted to understand through this paper. We did not wanted to go into the much detail, but still, if you want, it is a very good research paper. You can look into how they are doing. They are actually telling you how a matrix can be represented as an image and how an image can be represented as a matrix, and what are the different things that you need to keep in mind. So all through the paper you can look into what are these different values. So corresponding each matrix, they have given you what is the image, how you can change that, what is the complex matrix presentation, and all of those stuff. Okay, so yes, so has everyone understood the part that we wanted to look into? We from this, the purpose of us looking at this paper was only to understand that a image can be represented in the matrix form, and how can it be represented in the matrix form. So you see, corresponding every pixel, so every image has a pixel matrix first of all, and corresponding every pixel you're going to have a value in the matrix, right? So any doubts in understanding this part, wherein we are saying that the image can be represented as the matrix? Can you now understand how it is done? Okay, okay, so let us move ahead. Let us continue where we left. So let me just again uh, share the PDF with you, the OneNote document. So is the document visible to everyone? No, red, blue, green are not called grayscale images. We are saying that any colored image can be represented using three grayscale matrices. We are not saying grayscale images, we are saying grayscale matrices here. Okay, so if the screen is visible, let us continue. So, like I said, we looked into this paper where we understood that an image can be represented as a matrix. So this mat here actually represents the same thing. So you have an object of this mat type. An image can be represented in the form of the matrix, and this image that you're now going to load using the imRead function is going to be represented by an object of type mat. Okay, so yes, let us continue and also understand what is this function. So let us understand what is imRead function. Let us also look at its syntax. So we say, so when we talk about the syntax of imRead, we say that how can you write this? You say imRead, which is image read, and within double quotes you are going to mention the file name or the image name, you can say, and separated by a comma, the other argument that you have is a flag, and this flag is of type integer. So let us understand what this flag represents and how can you write this. So this particular argument, which is the file name, can also take up the complete location. So like you write, let us say your file or image that you want to now read or load is stored in the D drive. So you simply say D and whatever folder it is in. So let us say it is inside my folder, and the name of the file or the image is, let us say, flower.jpg. Okay, so you can also write this complete thing here as well. If you only write down, like it happens for any particular function or method, whenever you write only the file name or the image name, it is going to search for this image in the same directory in which you have this particular code. So in order to access this, if your uh, image is not in the same directory, then you can mention the complete path as well. Okay, so this is about the first argument. Let us look at what is this flag argument. Now there are different ways in which you can actually read or load an image. So for that you can also use this flag. So you have imRead underscore unchanged. Yes, in the file name, we also include the file format. There are different file formats that are supported. So let me also write down what are the different file formats that are supported. You say JPEG or even JPG. You can say BMP is also valid. PNG is also valid, and you have TIFF that is also valid. So all of these are actually those file formats that are valid for reading using the image read function. Okay, so yes, let us continue to look at the flag here. So you can have three different types of flags, which is imRead flags. So it can be imRead grayscale. You can have imRead so these are underscores. If you're getting confused with these are underscores. You say color. Okay, so for this image read function, you can have three different kinds of flags that can appear in this here. And if you do not, let us say, write down the flag under the arguments whenever you call this function, then it is going to take up the default flag, and I am not sure about which of these is the default flag, but I think it is this imRead color. But anyway, as these names suggest, you can look what is the default online as well. I cannot recall it for now, but yes. So let us understand what these flags are. So as the name simply suggests, whenever you want to load a colored image, you say that I want to load this image in color. If you have an image which is in color and now you want to import it in the grayscale form, you can say imRead grayscale. And otherwise, if you want to load the image as it is, you say imRead unchanged. So this is simple flag that you can use, a simple function, imRead function. Only remember the syntax, which is you in double quotes you mention the name or the path of the image along with its extension, and the flag, if you want to say load the image in any particular form, you can mention any of these flags, and then you whatever is returned, you set it to a object of type mat. Okay, so this is about simply about a function, which is how can you load or read an image, right? Let us move ahead and let us see what are you going to do next. So for any image processing project, you will have to obviously load or read an image, which you now know how you can do that. Now once you actually load it, there are some let us say error checking that you have to perform. Okay, so for that you can actually check if, so what happens when this image is not properly loaded, or say suppose if this image does not exist. You have mentioned an image name here and you have let us say that image does not exist, or if say suppose you mention the image name only, and this image is not in the same directory but in some other directory, then imRead is going to return an empty object. So the empty object will be initialized inside this mat image. So for that you are going to keep a check. So what do? You check if image dot empty. So you have this function here, this dot empty, this function empty function is simply going to check if this object is empty or not. And if this, let us say, if this image is empty, you can simply, let us say, print that error. Okay, you can say error in loading image or whatever. And yes, so this is about checking if the image is empty or not. Now, why do you think we will have to check the images empty or not? So Arnav is asking what is unchanged. So if, let us say, you do not want to change any particular image, and you do not actually, you have a lot of images that you want to read one by one, and you do not know in which particular format these images are. So you can simply use the unchanged format, which is load the image as it is. So if it is a grayscale image, load it anyway. If it is a colored image, load it anyway. Okay, so that is imRead unchanged. So yes, we were talking about this empty function here. So why do you think you need to check if this object is empty or not? Now say for example, you have loaded a particular image and you are performing some kind of processing on it. Okay, and you keep on processing it, and later on you display the result. Now what if the image object or the image did not load properly, or let us say the image object is empty in this case? So all of that time wherein you were processing the image and then showing the resulted image is a waste, right? And also it is going to throw an error and your program can crash. If you're working on, if you're processing an empty image, it is going to okay, give me a moment everyone. Yes, let us continue. So as I was saying, so whenever you are, let us say, having an empty image, in that case you do not know how this image will be uh, uh, you know, going ahead in the flow whenever, let us say, you are processing the image. So you will be processing an empty image and wasting time as well as your resources. So for that you can simply put a check here that if the image object is empty, I should not go ahead. So for this you can simply say that I want to, let us say, do scene get for so whenever you throw an error, you simply say that okay, wait for the user to press a key and then return from this program. So say return -1, let us say, for example. And yes, so this, only this particular error handling will help you a lot. Otherwise what will happen, if you're working on an empty image and processing it and then showing it, at some point of time your program is going to crash and you won't understand where the problem occurred. So simply put in a check here, empty check here, which is going to check if the image has properly loaded or not. Okay, so this is about the empty function. Okay, so Pratyush is asking how to initialize the flag to unchanged grayscale or color. So this is the flag itself. So when you write this, this is the flag itself. So say for example, you want to load this flower.jpg. So you say imRead, and inside this, let us say your image is in the same directory, so you say flower.jpg, and here you write imRead and let us say I want to uh, open it up or load it in the color format. So you say color. Now this, all of these, this whatever I have mentioned here, this complete statement is equivalent to an integer. Okay, so this is, I don't know what are the specific values, but I think it is 0, let us say, for this. This is corresponding one, and this is, let us say, I think 2 or whatever. So these are actually integer values which are predefined. So you can simply write these down. So that is why I have explained you how you can do this. Instead of writing 0, 1, 2, whatever, you can simply mention these. Okay. So this is how you can initialize the flag here. You do not need to actually initialize anything to these. These are already initialized and predefined. So you can simply mention them here inside the function. So now we have talked about the empty function and how you can see if the image is, let us say, empty or not. Now let us move ahead and let us understand how can you display a particular image. So, so for displaying a particular image, we say that you will first require to create a window. Now, what do you mean by a window? So, let us say, so you might have opened any particular image on, let us say, your laptop or on your computer. So whenever you double click on an image, it is going to open up, let us say, in the Photos software. So it is going to open up a separate window, right? It opens up in a separate window which you can actually cross or minimize or change the size. So that particular thing is known as a window. So here also, whenever you are actually working on, let us say, a small image or any particular image, for that case, you, for showing that particular image, you will have to create a window here. Okay, so the window is not automatically created, you will have to create it on your own. So is this part clear? Do you understand what a window is? Can we move ahead and look into uh, how can you create a window? So up till now, is everything clear to you? Have you understood what are the different ways that we are looking at? What are the different statements we are understanding here? Also tell me if you've understood the concept of a window. Why are we going to create a window? Did you understand that? Okay. Okay, if you have, let us move ahead then. So let us look at how can you create a window. So for creating a window, you have a function known as named window. You call it, this function is known as named window, and inside which you can pass an argument which is window name. So what happens in this case is, so let us say you have worked on a particular image, you have loaded a particular image like we have did here. Here you are loading an image, you are saying I want to open up this image flower.jpg in the color format, and for that you will require a window, as I said. So now to this window you are giving a name. So like you can see here, this is the OneNote window that I have opened here. This window is OneNote window, and this window has a name. So you see this window has a name here, which is L6 Lecture 6 Winter Programming Bootcamp. So similarly, for the window in which you want to show your image or display your image, you will have to give it a name. So using this particular function, you create a window and give it a name. This named window function will first create a window and it will initialize this name to it. So simply say, suppose you have a string here, which is, let us say, window name, and to this you are initializing some name. Let us say you are giving it a name as my flower image. Okay, so you have this string here to which you are saying you named this string as window name and you have initialized it as my flower image. So now you are going to, using this function, you are going to create named window of window name, which is my flower image. Okay, so this is going to create for you a window with a name here. This, what will this name be? This name will be my flower image. Okay, now after you have done that, let us also understand this named window function. So as you already know, as I have explained here, it is going to create a window for you. Now say, suppose if a window already exists with this name, so then it is not going to create a new window for you because this window name already exists. Say, suppose if you create another window and give it the same name, it is not going to create a new window for you. It is going to have the same window. Okay, it is going to consider that you did it by mistake. Anyway, so this function also has a kind of a syntax, let us say. So you say syntax for named window function. So the named window function, so how do you, let me write down how do you write it. So you say named window, and here you are going to mention the window name, and again you have some flags here. Okay, so these flags are again integer type of flags, and these flags, let us look at, so like in the ImRead function you had 3 flags. You have 2 different flags that you can mention here inside the named window function, and those flags are window auto size and window normal. Okay, so these are the 2 functions that you can have, sorry, not functions, arguments or flags that you can have. So what do these stand for? So this stands for, when you say window auto size, it means that it cannot resize the window. You cannot, whenever the window opens up, you cannot resize the window. So this you can see in this OneNote window that I have opened up here. You have this function, this feature here, which is, using this feature you can actually resize this window, है ना? When you click on this, it is going to become small, and then when you again click on it, it is going to become full screen. So using window auto size, you will not have this feature, which is you cannot resize the window, and using window normal, you can actually resize the window. Okay, so this is the only flag that you can have, and only these 2 flags can be used inside the named window function. You can simply create a window of the given name with any of these features. If you, let us say, do not want to resize it, it will not resize, and window normal is going to be able to resize your window. Okay, so this was about named window function. You have the named window function. Now you have loaded the image using the ImRead function. Using the ImRead function, you have loaded the image, and you have also checked if the image is empty or not. And let us say our image is not empty. And now you have also created a window in which you are going to show your image or display your image. But you have only created the window, you haven't up till now displayed the image. So for that, for displaying the image, you have the im show function. Like you have the im read function to read the image. To show the image, you have the im show or image show function, in which the first argument is going to be the window name that you just created in order to show your image. So you say window name, and you mention which image you want to show in this window. So you loaded the flower image inside this mat object of type image, right? So here you can see inside mat object image, you loaded the image that you want to show, which is flower image, say for example, and then you created a window of name. You created a window of name my flower image. Okay, so now you're telling using this function im show that I want to show this image, flower image, inside this window which I have given the name as my flower image. So it is for you going to open up a window like this, and in this window you are going to have the name my flower image, and here you are going to have what this image will be displayed, whatever image you want to open up here. Okay, so this is the im show function. Any doubts to anyone up till this particular part, up till understanding the im show function? Which of these windows will be default? I really cannot recall which of these flags are going to be default. You can go ahead and check about this online, about which of these flags will be default. So say sometimes you do not want the image that is opened up to be resized, right? So in that case, you can simply say that I want it in the form of window auto size. Now, you won't understand the use of flags right now because you are not much into image processing, but to whomsoever who actually attempts image processing on a regular basis, they will require to open up and resize the image and look into different pixels. Okay. Okay, shall we move ahead, everyone? No, so like I said, since we've already included a header file, which is for us going to include other header files, whichever are required in our application for now, so we do not require to include a header file. How to store an image in a matrix form and display matrix as an image. So yes, that can also be done. So for that particular part, you have separate functions. So you can go ahead and look into those functions as well. Everything is available online. So this is something that is going to be your actual project. Okay, so the second argument of the im show function. So in the im show function, let us move ahead with this. We are saying that in the im show function, we have two arguments. So the first argument is the window name which you have created, in which you want to display your image, and the second is which image you want to display. Okay, so the second argument of the IAmShow function is basically the image that you want to show. So the image that you want to show will come as the second argument, and the first argument is the window that you have created in order to show this particular image. Okay, so I hope that is clear to you. Okay, so we for creating an image you have separate functions. The function is named as image. In this function you can simply mention what is the height of the image, what is the width of the image, and in which format do you want the image to be. Okay, so let us move ahead with the IM. Since we've looked into the IAmShow function, so now what happens after you have written down this particular piece of code? Now here you have created a window, you have displayed the image. Now let me write down what are the next two steps that are going to happen. So which is wait key, and the next one is destroy window. So once you have created a window, you have used it, you have displayed your image, and you want to, let us say, end the program, or your processing has completed and you have displayed the image, then you should destroy your window. So for that you have this simple function, destroy window is the name of the function, and you simply pass the window name that you had created earlier, and it is going to destroy that particular window for you. Now what is the purpose of this wait key function? So the wait key function is going, so as soon as you show a particular image, so say for example you have created this complete program. Now this program is something which is written in green. All of that is written in green is the complete program which you can use in order to read a particular image, show it, create a window for it, show it, and end the program. So once you have done this, you have, let us say, read the image. After that you checked if the image is empty or not. After that you created a window for the image because you wanted to display the image, and then you simply displayed the image. And if you do not have this function in between, which is the wait key function, and you simply destroy the window, then what is going to happen? When you run the program, for an instance, you will quickly see the window and the image, and it is going to be quickly destroyed because the next function that you're going to have after IAmShow will be destroy window. So here you put this wait key function. The wait key function here is going to stop the program execution for a key press, and as soon as you press a key, it is going to continue the program execution. Okay, so what happens? You display an image, then you wait for the user to actually press a key, and once he presses a key, then you destroy the window and end the program. Right? So has everyone understood the purpose of wait key function here? Okay, so if you have letters, then okay, so this is basically, so whatever piece of code that we looked at today is basically how you can actually simply use some of the functions and, let's say, only one header file in order to read a particular image, check if it is empty or not, check if create a window for it, show or display the image, wait for the user to press a key, and simply destroy the window and end the program. So this is what we looked at today. Now for the project part that you have to perform, what you have to do is you have to go ahead, research about this online. So before understanding what these functions do, if you didn't say, for example, if you didn't know what these functions were doing, you wouldn't understand what actually a window is, you wouldn't understand what the im show function is doing, or let us say not understand what is the destroy window function is doing. So now I want you to do is, you go ahead online, research about the different functions that you can use, and create a C++ program, or write down a C++ program after installing OpenCV and VS Code. You should be able to create a program which is going to read a image, that is input a image, and then also input a angle. So let me write this down. You say input an image, okay, input an angle, and rotate the image by the angle given. So this is the processing part. You rotate the image by the angle given and then display the image. Yes, so you can use any function which is going to wait for a key press. It can also be cin.get. Okay, so this is a part of your homework, or whatever you say. This is going to be evaluated. You are going to go ahead, like you understood about the functions in this way, you are going to see what are the different functions that you can use in order to rotate an image by a given angle. And for that, you are going to take an input image from the user. So let us say input an image and then input a particular angle at which the user wants to rotate the image. Rotate the image by that particular angle and simply display the image. So this is the project that you're going to create. You're going to use C++, you're going to use all the inbuilt functions that are provided by OpenCV. Okay. Yes, that is what I said. You can take the user's input in imread for his choice of image to process. You can do that. Good. So is this clear to everyone? How to submit the project? So for now, you have to just first create the project. We are going to talk about the submissions later on, but so I am not really giving you a deadline for this particular project, but towards the end of the bootcamp, we can ask you to actually submit this particular project. Okay. Should the angle be a multiple of 90? Okay, so no, because now when you, so I don't really want to go ahead and tell you about this, but whenever you are going to be looking at the different functions, so as I said, you are going to do it using an inbuilt function. So first look at what is this inbuilt function that you can use in order to uh, rotate an image and by a certain angle. So it is going to take an input of the angle as well. So you do not really need to be specific with the angle in terms of, let us say, like you are saying that should it be a multiple or 90 or not. So it can be any angle that should be asked by the user. And since this is going to be done by an inbuilt function, so that shouldn't be a problem. So that is totally your own choice. You want to do it clockwise or you want to do it anti-clockwise, totally up to you. I'm keeping this part to you only. that you can rotate it in any direction you want, clockwise or anti-clockwise. So if any one of you have any doubts regarding what we have looked into today, or what is the project that you have, the image processing project that you have, then you can post any of your queries in the group. And for others who do not have a doubt, uh, we are going to end the class for now. You can leave if you want. The only thing that you have to keep in mind is that you have to attempt this using C++ and OpenCV, install OpenCV and VS Code like we discussed, and use all of these things that we've discussed. We've looked into the basics of image processing. Do this, and your fully working code um should be something that we can ask you to submit at any point of. Now, am I audible? See, we looked into what OpenCV is. So OpenCV is basically a library which is open source, and it allows you to perform computer vision. What is computer vision? Computer vision is actually extracting useful information from images, videos, and text. And then we looked into what are the different applications and what all can you do using image processing. So the first thing was facial recognition and object recognition. So any kind of recognition can be done using OpenCV. It also involved counting the number of people, the number of objects, number of vehicles, and any such things. So all of this comes under automated surveillance, right? And then the other thing that we looked into that can be done using OpenCV is anomaly detection, which is, let us say, if you have manufactured a set of products and you want to find out the defective products, that can also be done using OpenCV. Next, we looked into how can you start off with OpenCV, and we simply looked into a piece of code and understood statement by statement what each statement does and how can you start off. So we said that you are going to first of all do this. So whenever you are going to start off with your project, you install OpenCV with VS Code. We have discussed this, uh, that if you use OpenCV on Linux, it becomes a bit complex, but still, if you like it that way, you can do that. Otherwise, VS Code is a good option which you can use. And then we moved ahead and looked into the libraries that you can use. So the header files that you have under this library are, let us say, there are a lot of header files, but for now, to start off with, you can actually include this header file that has been given here, and it is automatically for you going to include all the necessary header files that you are going to use in your application. Then we looked into the namespace that we use. So the namespace CV is used to include all the necessary functions and classes that you will require and you will use in your application. Now, since we were looking into image processing specifically, so we started off by looking into how are you going to read read or load a particular image. So we started off by writing the program by including the header files and by writing down the namespaces. Then we started off with the main function. Inside the main function, we use this function, which is the imRead function. The imRead function is going to read or load a particular image for you. So it uses two arguments. The syntax for imRead function is to use two different arguments. So the two arguments that it uses is first the name of the image or even the path to a particular image, and the second is a flag. So there are three different kinds of flags that you can use in the image read function, which is imRead unchanged, imRead grayscale, and image read color. So if you want to load an image in the color format, you can use this imRead color. If in the grayscale format, imRead grayscale. And if say suppose you do not know which is the format of the image and you want to load it as it is, then you can use imRead unchanged. Okay. And now we are saying that this imRead function is going to return you an object, and it is going to store this particular object into an object of type mat. We also looked into what this object is. So we say that any particular image, any particular digital image is stored in the form of a matrix. So for a grayscale image, we have a single matrix. For a colored image, we have three matrices, and they are going to represent our image. Okay, so that is why we have this mat class, and you have the object of mat class in the that is going to store your image. Okay, now next, after you have loaded the image, you simply, what do? You simply check if the object is empty or not, because what happens sometimes, say the image is not loaded properly, or if it happens that the image is not found, in that case this object, this image object of mat type remains empty. So in order to avoid program crash, you check before processing the image, you check if it is empty or not using this empty function. And if it is empty, you simply see out or put on the console that there is an error while loading the image, and you return. Okay, if the image is not empty and you can now further process the image. So say if you want to display the image, so for displaying the image you will have to create a window. Now what is the purpose of creating a window is this, that say for example, so whenever I gave you an example of what happens when you double click on an image on your device. So when you double click an image on your computer, it happens to open up in a separate window, right? In a separate window opens up, which has the image name here and the image that is displayed to you. So similarly, in order to display a particular image, you will always have to first create a window. Okay, so without creating a window, you won't be able to display the image. So that is the purpose of creating a window. So how do you create a window? You use this function named window. The function name is named window, and to this you pass the window name. So like here I have written down the window name inside double quotes, and I have put in inside the named window function as the argument. So what is, let us also look at the syntax of the named window function. Inside the named window function, you have window name and the flag. So there can be two different types of flags here. The first is window auto size, the next is window normal. So window auto size, if you open up a window and you are creating, let us say you're creating a window with the flag window auto size, then you won't be able to resize that particular window. And if you're doing it window normal, then you can simply resize the window. Okay, so this is simply how you can create a window. So once you have created a window, now let us say you want to display the image. So for displaying the image, you are going to say imShow. The imShow function is going to display the image, and using the imShow function, what are the different arguments that you need to have in the imShow function? In the image show function, you need to have the window name that you have created in order to show the image, and the image name that you want to display in that particular window. Okay, so this is simply about imShow function. Then you have two different statements, which is wait key and destroy window. So whenever you create a window and you have processed the image and displayed the image to the user, you will have to destroy the window as well. Okay, so before ending the program, you destroy the window, but Now what happens, as you run the program and you say show the image and then destroy the window, it is going to happen in one instance, so you will not be able to look at the window for a longer duration. So to do that, you use this wait key function. The wait key function is going to stop the execution of the program until you press a key. So as soon as you press a key, it is going to continue the execution of the program and then destroy the window and the program would end. Okay, so that is the purpose of wait key. Now the project that I have told you to do is to input a particular image, input an angle, or if you want, you can input the direction of rotation as well. Then you process the image by rotating the image in a given direction by the given angle and simply display the image. You can do all of this using uh, uh, some inbuilt functions that are again provided under OpenCV library. So yes, do that, and that is the simple project that you're going to attempt. You're not being given a test today because we are expecting that you are going to be performing this particular um, uh, performing or attempting this particular project. So you have Saturday as well as Sunday to attempt this project. On Monday, we might ask you to submit this project. All the submission instructions will be given to you later on. You can also have a scheduled, let us say, submission of this particular project towards the end of the bootcamp. So this project is again, if it has to be mentioned in this way, it is mandatory for everyone to do this. And yes, so that will be all for today. If you still have any doubts, you can post it in the group. Otherwise, thank you everyone. Let us meet on Monday. And if, let us say, you have any queries regarding the project, those can also be posted in the group at any point of time you find that you are stuck somewhere, or you can contact me personally. Yes, there is no class tomorrow. Okay, so if there are no doubts, thank you everyone. Let us meet on Monday